this problem, we're given the graph of a derivative of a function. Just by looking at the derivative, we can determine whether the original function was increasing or decreasing by looking at the signs of the derivative graph. When the graph of the derivative has a value greater than 0 or above the x-axis, then the original function graph is increasing. And when the derivative graph has a value below the x-axis, then the original function is decreasing. We also know that when the graph changes signs from, say here, going from negative to positive, then the graph will have a minimum. And when the graph changes, or when the derivative graph changes from negative to positive again, it has another minimum. Therefore, the original function graph has two minimums, one at x equals 0 and one at x equals 4.26. We also know that the graph won't have a asymptote because it is given to us that the derivative is a continuous function, or the original function is continuous. The second part of the question asks to find the second derivative graph given the first derivative graph. Since we see that there is this part where the derivative has a linear part with a slope of 2, then the second derivative graph will just have a graph of y equals 2. And from x equals 2 to x equals 5, the graph is quadratic and it changes from a negative slope to a positive slope. Therefore, the second derivative will have a x-intercept at this point 3.13. And since it goes from negative to positive, the graph has to go from below the x-axis to above the x-axis. Finally, the question asks to find the original function graph given the initial condition that f of 0 equals 3. So the point 0, 3 is one of the points given, and the range for x is between 0 and 5. So we'll be ignoring this part from negative 1 to 0. Now, since the first derivative has a positive slope and the second derivative is positive, the graph will be above the x-axis and concave up. And now, since the first derivative is below the x-axis, and so is the second derivative, the part between x equals 2 and x equals 3 will be concave down, and the point from x equals 3.13 to x equals 4.26 will be concave up since the second derivative is positive here, and the first derivative goes from a negative value to a positive value. That'll make it the original function have a positive slope or negative slope and then a positive slope of the derivative.